Hi everyone, welcome back to Sea Dog Science. Today we're going to take a look at this reaction and do a few stoichiometry calculations. So here's my reaction. Carbon monoxide plus oxygen gives us carbon dioxide. Already balanced, 2 to 1 to 2 mole ratio. What I want to find out is how many grams of O2 react with 10 grams of CO. CO is my reactant. We're going to figure out how many grams of O2 react. So that's a gram to gram stoichiometry question. We're going grams of one chemical to grams of a new chemical. So we're going to start with the 10 grams of what we know. So 10 grams of CO. I'm going to write that down right here. 10 grams of CO. Now we're going to set up our unit conversions. If I want to change my chemical, I can't use grams. I have to use moles. So my first step is to get this into moles. And then after that, I can switch the chemical using the ratio. So step one is just to get this into moles. So I'm going to multiply that. Find the molar mass of CO together, so you can do that with me. Carbon's about 12. Oxygen's about 16. And my molar mass for CO is 28.001. So I'm going to write that down. Now, 28.001 is the amount of grams that are in 1 mole. If we're going to moles, we need 1 mole on top because that's where we're going. So 1 mole goes on top. 28.001 grams goes on the bottom. So that's what you're seeing here. Now I'm at moles, and I'm at moles specifically of CO. I haven't changed my chemical yet. Now I'm going to change my chemical. So I'm going to draw a little box to indicate that I'm using my mole ratio. And inside the box, I'm trying to get, in the question here, how many grams of O2. So I'm going to O2. There's a 1 out front. So I'm going from 2 to 1. How do I go from 2 to 1? I divide by 2. That means the 2 moles of CO is going on the bottom to cancel out. So 2 moles of CO. And there's 1 mole of O2 for every 2 moles of CO. So that's my fraction setup. And then finally, we're going to go back to grams. Now I'm at moles of O2. I can take moles of O2 and get grams of O2 by multiplying by the molar mass. Put the grams on top because that's where we're going. The molar mass of CO2, the molar mass of O2 is 2 times the 15.999, which is 31.998. So 31.998 grams is in 1 mole of O2. So all your units cancel out. The grams of CO, the grams of CO cancel out. The moles of CO cancel out, and the moles of O2 cancel out. Now we're left with grams of O2. So when you do this calculation, you're going to do the 10 times the 31.998. I'm going to hit enter. Then I'm going to divide by this number, divide by 28.001. Hit enter. And then finally, I'm going to divide by 2. And hit enter. And I'm getting 5.71 grams. So I'm going to fill these little boxes above with my gram amounts. So CO right here, we started with 10 grams of CO. So I'm going to put 10 grams in the box. And we just calculated that we now have 5.71 grams of O2. Okay, we back. So now I'm looking for how many grams of CO2 are produced from my 10 grams of CO. So same reaction, same starting value. Now we're just going to get the grams of CO that come out, and you're going to notice something really cool. Sorry, CO2. When you do the setup, you're going to set it up the exact same way. So we're going to start over here with my 10 grams of CO. We're going to use the same molar mass to get that into moles. So step 1, get this grams of CO into moles so that I can change my chemical into CO2. So we're going to set up the times sign. 1 mole on top because we're going to moles. On the bottom here, I'm going to put my 28.001. And now I'm at moles of CO. Now if we're going to go to grams of CO2, first of all, I have to change my chemical. So I'm going to use my mole ratio. Specifically here, I have 2 moles to 2 moles. So it's a 2 to 2 ratio. That's really nice. That's kind of like multiplying by 1. So I'm going to write it all out so that you can see it. Basically, it's 2 moles of where you're going, which is CO2, over 2 moles of where you came from, which is CO. So far we're here, and now we just got to finish this off. I'm at moles of CO2. I need to get grams of CO2 times the molar mass of CO2, 2 oxygens plus 1 carbon, should give you about 44.009 grams. So 44.009 grams is 1 mole. And now all you have to do here is multiply on top, divide on the bottom, and you're all set. So if you take your calculator, we're going to start with the 10. You're going to multiply by the 2 on top. And if you just want to simplify this, you can. And I actually might do that to do less work here. So I'm going to take the 10 and immediately go over to the 44.009 and multiply them. And then I'm going to divide by this number, 28.001. I'm going to hit enter, and then finally I'm going to divide, and actually you don't even need to do this step because we already simplified it. So all I did, 10 times 44.009 divided by 28.001. And I got an answer of 15.7. And something very interesting happened here. I made 15.7 grams of CO2. We'll take a look. 10 grams plus the 5.71 grams gives you 15.7. Oh look, conservation of mass. It works. It all works. The math works and proves that no chemicals can ever be just created or destroyed out of nowhere. And you're done. So that's the magic of this math. Okay, everyone, now we're going to go to liters. So I want to know how many liters of CO2 are produced from our 10 grams of CO. So really, really fast, let's start the exact same way as last time. What did I just do here? I took the grams of CO and made it into moles. So now that I'm at moles of CO, I can change my chemical to CO2. So let's do it. CO2 is, nope. Okay, now how did I get this number? I got this number because I'm trying to go grams of CO to moles of CO so that I can switch my chemical. So just like last time, now I'm at moles of CO and I can change my chemical. So we're going to change the chemical to where we're going, which is CO2. So I'm going to really fast write the ratio again. Okay, ratio's written. Now my final step here, we're going to assume that this is at STP. Now STP isn't really, we're never going to use it in reactions because good luck reacting something outside when it's winter time at exactly 32 degrees Fahrenheit or 0 degrees Celsius. Not going to happen. But this is just a nice way to calculate liters to introduce you to this. So once we're at moles of CO2, we are finally going to go back to, not to grams this time, to liters. So it doesn't matter about the molar mass. All you need to do is put 22.4 liters on top. You'll put 1 mole on the bottom, and it's 1 mole of CO2. So everything cancels out except for liters. And then we're going to do the multiplication. 10 times 22.4. I'm going to ignore this again. 10 times 22.4 divided by 28.001. So let's do that. And I'm pretty much getting exactly 8 liters. So 8.00 liters That's pretty awesome. All right, we back in business again. This time, this is my last question. We're going to figure out how many liters of each reactant produce 10 liters of CO2. And we're going to see if conservation works with liters or if it doesn't work with liters. This will be interesting. So let's take a look. We're going to assume that it's at STP again. We're going to start with my 10 liters of CO2. So let's write that down, everybody. 10 liters of CO2. And because I want each reactant, we can write it down twice. There are 2 reactants. Now, if I'm going from liters to liters, same thing. We're going to get it to moles, switch the chemical, then get it back to liters. So let's do it. I have 10 liters of CO2. I'm going to get that to moles. 1 mole over my 22.4 liters. Then I'm going to take it through the ratio. The ratio here, now let's pick a product. I don't know, let's say we want to get the CO reactant. All right, I start with my CO. Let's get to let's go from CO2 to CO. On top, I'm going to put 2 moles of CO over 2 moles of CO2. And then finally, once I'm at moles of CO, I go back to liters. So times 22.4 liters over 1 mole. And I'm getting, well, look what's nice about this. Look, 22.4 goes bye-bye. So 10 times 1, this is just 10 liters. Look at that. That's pretty cool. So liters works the same way as moles in a ratio, right? If you have 10 liters of CO2, to get from 2 to 2, you don't do anything. You multiply by 1. So if I have 10 liters of CO2, I also have 10 liters of CO, which means if you think, how many liters of O2 would I have? 2 to 1 divides by 2, so I would have 5. Now let me quickly do the math to show you. And here we go. So it's the same math, except this time the ratio is different. I can go kill you, and now what am I left with? 10 times 1/2. Oh, look, it's 5. It's 5. Yippee. Now look at this. This is cool. Unfortunately, there is no conservation of liters here. And that's how gas reactions work. It's really cool, and you're going to learn about this later. If you have 2 plus 1, that's 3 total moles of gas. 3 moles of gas makes 15 liters, and 2 moles of gas makes 10 liters. It's following the ratio. If 1 mole of gas, any gas, 1 mole of gas makes 5 liters, then 2 moles of gas makes 10 liters, and 3 total moles of gas makes 15 liters. So moles of gas, or moles of anything in a reaction, are additive. It's really cool how this works. So here's a little extra something. This is how stoichiometry of liters works. Have a nice day. Good luck tomorrow.